Hello students, so we are going to discuss the solution of the test paper on moving charges. That's the first test paper. Let us discuss. The question number 1. An electron enters a region that contains magnetic field. So in the question what it is given is there is a electron. This electron is entering like this and this angle is given as 30 degree. This is x-axis and this is y-axis, right? So note that electron is a negative charge, so charge is of course minus E, the value of E you know, right? So charge is a negative charge, right? And magnetic field is like this way. Magnetic field is like this way, cross. What is cross magnetic field means? Cross magnetic field means magnetic field is inside, right? Question is, what is the direction of magnetic force on electron when it enters? So when it is going to enter inside that, what is the force, direction of the magnetic force? That's what the question is. So clearly you can see that the magnetic, this is the direction of velocity. Let us say this is velocity and magnetic field is inside. So what is the direction of V cross B? Suppose this is V and B is inside. So V cross B, when you do, the force direction will come this way, right? Force direction will come this way, magnetic force direction. Why? Because magnetic force is equal to Q V cross B. But note that here charge is negative, so instead of the force being in this direction, force will be in this direction. You have to note that. Because the charge is negative, the force will be opposite of minus V cross B. That means opposite of V cross B. This is V cross B direction, right? So perpendicular to that. So this direction will be the magnetic force direction, correct? That direction is magnetic force direction. Now look here, look here the angles, right? So this angle is 30 degree. Look here, the angle is 30 degree. This angle is 60 degree. So this angle is also 60 and this angle is also 30 degree, right? That's all. Over. Now you match with the option. So the magnetic force, it is at an angle of 30 degree below the positive x-axis, right? That is the correct answer, because if you consider this as x-axis, so this angle 30 degree is below and that's the direction of the force, right? You should be clear about that. This is the direction of the force. Why this is the direction of force? Because q v cross b, direction is this way. This is the direction of v cross b. Note that this is the direction of v cross b. But when you put the charge here, because charge is negative charge, this direction will reverse. So the direction of the force will be this way. It will be making a 30-degree angle with the x-axis, right? So the option number B, that is the correct option, right? Let us move to the next. Question number 2. Let us take second question. Second question says that there are some paths are given. One path is given, one particle is going like this way, some path is given. And another, for particle 2, second particle is going like this way. How is magnetic field directed outwards? So magnetic field is outward means dot dot, dot dot. Coming out, magnetic field here is coming out, okay? Magnetic field is perpendicular and it is coming out of the plane, dot dot. Okay, this is the trajectory they have given. Which one of the following statement is true? Particles have both neutral, positive, negative. So first we need to decide which is positive, negative. Definitely they are charged particle, because neutral particle will not move in the magnetic field, right? So it is going in a circular path. So first of all we need to think about direction. Suppose if I choose here, let us say for example here, if I consider At any point here, if you take, suppose if I take here, this is the direction of velocity. Velocity direction is tangent, right? So velocity direction is tangent, and this force is in this direction. Force direction, clearly we can see force is in this direction. Why? Because the center will be here. It's a circular path. It's a circular path. So center will be this side, right? So center will be this side. So the magnetic force must be this way. Suppose if the charged particle is positive, so V cross B direction, where is the B? B vector is coming out. So V cross B, if you do, it will come this way. So force is coming this way, means this charge must be negative. This charge, first charge must be negative charge. Negative. Why? Because V cross B is coming this way. It is force is opposite of V cross B, so this is a negative charge. Now see about here. Here you see. Here also take, this is the direction, this direction is the velocity direction, and magnetic field is coming out. So what is the V cross B direction? Try to find out V cross B direction. So V is this way and B is coming out. V cross B is coming this way, right? V cross B is coming this way. Cross product, if you do not know, you will have problem. Okay, V cross B will be coming outward, means magnetic field is coming outward. V cross B direction is this way. So if V cross B direction is this way, but the center is lying this, again this must be negative charge. So second particle also must be a negative charge, negative. So if you do not have the idea of V cross B, you are in problem. Okay, V cross B or right hand thumb rule you should know. So suppose if I take V and V is coming outward, so V cross B will give this way, but the center is this side, so force is this side, that means charge must be negative. Okay, same thing is happening, same thing happening there also. So both these particles are negative charge, right? So correct option is option D. Particle 1 as well as 2 is negatively charged, right? Let us move to the next question. Question 3. Proton is traveling with velocity v enters a region of magnetic field perpendicular to the original direction of the proton. Which of the following statement is true? So suppose if there is a charged particle, it is going with velocity v, magnetic field is perpendicular. So suppose magnetic field is cross. Let us say magnetic field is cross, or you can take as dot also. So you know that it is going to move in a circle, and V cross B direction is which one? So B is going inside, V cross B will be this way. So this is the magnetic force. If it is positive, right? It's a proton, so it is a positive charge. So that means it is going to move in a circle like this. It will turn like a circle. Now the thing is that in this circular motion, you should know that the speed does not change. Velocity direction only will change. The speed remains constant. The speed remains constant. Why speed remains constant? Because force is perpendicular to velocity. Force will not change the velocity, but it will change direction only. It's like uniform circular motion, right? So velocity particle remains constant. No. Speed of the proton remains constant. Yes. O direction and speed changes. No. Speed remains constant. Direction changes. Direction of proton remains constant, although its speed increases. No. So the only thing that is correct is speed does not change. Speed remains constant, direction changes. It is a uniform circular motion. That's all. Okay, so second option. Let us move next. Question number 4. A positive charged particle enters with magnetic field parallel to its direction of motion. So positive charge enters a region with magnetic field. Suppose magnetic field is this way and charged particle is also having velocity parallel. So velocity and magnetic field are in same directions, right? Then the subsequent motion trajectory. What will be the subsequent motion trajectory? So you know that here force, magnetic force is going to be 0. Why 0 vector? Because force is 0, because velocity is parallel. Velocity is parallel. Q V cross V. So V cross V is 0. So force is 0. So it doesn't get affected. Whatever way it is going, it will continue its motion in the straight line because there is no magnetic force. Assuming the other forces are not there. Okay. So it will remain unaffected. So the answer will be option D. not be affected at all, right? Next, question number 5. Let us go for question number 5. Following figure shows respective part taken. Okay, region containing constant uniform magnetic field. Okay, into the page. So there is a uniform magnetic field into the page like this way. Okay, like this. And they are showing here two part. One particle is like this, another is going like this. Both are circular motion you can take. Okay, so this direction of one of them, this direction is given. One of the particle is going like this way, right? Another particle is also going that means both are going clockwise, sorry, anti-clockwise. So this is particle B, right, and this is particle A. Both are going anti-clockwise. Okay, there is no electric field. Electric field is not that both particles have charge plus, both have charge. So the charge of, let us say, QA and QB, both the charge of QA and QB are equal as plus E. Okay, what can we conclude correctly about it? So you can clearly see the radius are different, right? Suppose if you take this as radius of B and this you take as radius of A. So you know the formula, radius is mv by qb. So radius of A is greater than radius of B. So radius mv is nothing but momentum. You can write momentum. So momentum by qb is greater than momentum by qb. Which momentum? This is for A charge of A. This is, sorry, this is B, right? This is B. So here definitely we can cancel out what, because charge of A and A are, we are same, B is also same. So definitely we can say that momentum is the product of mass and velocity, right? So momentum of A must be greater than momentum of B, correct? Momentum. Momentum, of course, when you take momentum, momentum is a vector quantity. Momentum is a vector quantity, but when you see, you can compare the magnitudes, right? Magnitudes you can compare. So if you go with this option, option C, magnitude of momentum of A is greater than magnitude of momentum of B. So magnitude of momentum, because radius we are comparing, right? So option C is correct. Let us move to the next. 6. Here it is given that one charged particle is going like that and it enters into some magnetic field like this. And then afterwards it enters into some magnetic field. So you can clearly see that in this region, there are two regions is there. One region is this and another region is this, right? So the circular motion which is happening here in this region and in this region, this is because of magnetic field present here, right? Now question is, here magnetic field is B1 and here magnetic field is B2. They are talking about the direction of magnetic field. What about the charge? Electron. Charge is nothing but electron. It is the electron. Electron means it's a negative charge. Okay. Now think about it. As soon as it enters here, here the velocity is this. Velocity vector is horizontal. And the force that is acting right now, here force is acting downward. So now you can think about the direction of this magnetic field. So V cross B. So suppose if the charge is positive, so V cross B. Thumb is coming downward means what is the direction of V cross B? Actual direction of V cross B. But charge is negative charge, so V cross B direction will be this way. Remember, V cross B direction is this way. Force is opposite because charge is negative. So V cross B direction is this way means definitely field will be inside V cross B. So that means this field B1 is inside means cross. What about this one? Now you check here. Here this velocity is this, right? This velocity is this. And then what is the V cross B direction? Again here V cross B direction must be this way. Why? Because force direction must be opposite of V cross B. Why? Because charge is negative charge. So if this is the force and this is V cross B, again you think about this V cross B, which direction will be magnetic field. Suppose magnetic field is coming outward, V cross B, then V cross B direction will be upward, right? So if I take this is the direction of velocity, and if I take magnetic field coming outward, so V cross B is upward, V cross B is upward, then because charge is negative charge, it will come as downward, right? So this means this V2 must be outward, V2 must be dot. Let us check the option. So B1 is into the page and B2 is out of the page. So that is option is correct. Option C is the right answer, right? Let us go to the next question number 7. Question number 7. So they are saying that a neutral particle at rest at A decays into two charged particles of mass m each. So there is a suppose a particle is there and it is going to break into two particles of equal mass, right? And this is like at rest. So in any collisions or any bomb blasting, the total momentum should be conserved. So initially it is at rest, so finally the total momentum is also zero. So momentum P must be zero. P of the system momentum, right, must be zero. So it is breaking into two particles, and suppose it breaks into two particles, so right now its mass should be 2m, right? Finally if it breaks, it should break into m and m, but whichever direction it will go in opposite direction. So this will go in this way and that will go this way, and they will go with the same speed, but velocity will be opposite, right? So what should happen? The magnetic field is inside. So magnetic field is inside. Let us say magnetic field is cross cross. Magnetic field is inside. You can break in any direction, but it has to be opposite, right? But you should know the radius formula. Radius formula is mv by qb. Now each of this particle, which you can take as particle 1, particle 2, right? Each of these particle have same mass and same speed, so their radius must be same. So radius of first particle should be equal to radius of second particle, correct? So now you choose option which have the same radius. So definitely C and D is not possible. C and D is not possible because the circle they have different radius. So you need to choose either one or two, first or second. Now which one will you choose, right? Which one? And they are going to collide also, because if their radiuses are same, then they will collide, right? So think about it, which direction it will go. Suppose it is upward and cross means this is inside, right? So it is inside means V cross B, which direction it will be, think about it. This is V cross B. So here the force will be, and also note that initially it is neutral. This is also important point to note, neutral. And it is becoming charged now, and then they must have equal and opposite charges. Magnetic field is inside. Neutral decays into two particles of each mass m. Magnetic field is inside the paper, which can be correct path. So if they have same mass, we can assume they have equal and opposite charge, plus q minus q. Because generally in nature, what happens if a particle breaks symmetrically, their charges also should be symmetric. So one is plus, another is minus. Somebody can argue that they may have opposite charges, but it can have different. For example, suppose if you say that this charge is mm, plus q, it has to be minus, it has to be opposite charge. There is no other way, right? Because total has to be cancelled out. Suppose if you take plus 1 coulomb, it has to be minus 1 coulomb. You cannot say any other charge. So their masses are same and charges has to be opposite because total charge has to be 0. Net charge of the system is also 0. So this you also see, the total charge has to cancel out, right? Now you think which direction they will go. Suppose here if I take V cross B positive, so for this particle force will be this way, right? This is the direction of the magnetic force. This direction magnetic force V cross B. So this particle has to turn in a circle like this way. It will turn like this. What about this particle? Charge is negative. So the force will be opposite of V cross B. So if it is V this way and B this way, V cross B will be that side. But opposite of that you have to take note that this direction will be V cross B direction. But you have to take negative because charge is negative. So this is the magnetic force direction. So now this particle has to turn this way, right? Definitely they will turn like this and their radius are same, so this will come somewhere and that will also be coming like that and they may hit. Definitely they will travel in opposite direction. One is this way, another will be this way, isn't it? So think about A and B, which options are possible. So collision will happen somewhere. So B is not possible because they are showing two different circle. It has to be same circle. Same circle is option A. Option A is same circle, right? Option A is same. Why this answer is coming different? Because I have chosen upper positive, below negative. If I choose upper negative and below positive, then you see what will happen. What will happen if I choose like this way? If I choose, for example, this as negative, so minus v cross b direction is what? Suppose I choose the negative particle is going upward, so v cross b direction will be which direction? Think about that. Other way also you can, this is one possibility. Suppose if I choose upward is negative and it is going like this way, right? So v cross b direction will be this way, v cross b direction, but force has to act this direction, right? Opposite. So now you will see that this particle has to go like this and other particle has to go like this. This diagram that they have given in the question, both are possibilities. So but circle will be one circle, two circle is not possible. So option A is correct. Fine, let us move to the next question. Number 8. Question number 8. A magnetic uniform magnetic field is directed into the page. A charged particle move in the plane of the page. So they are showing one charged particle is moving like a spiral like this way. This is the direction, the spiral direction. Magnetic field is cross into the page. Magnetic field. Question is, a charged particle is in the plane, spiral clockwise, radius, decreasing radius. Which is the explanation possible? Charge is positive, slowing down. Think about it. Suppose, for example, if I take right now here, so velocity is this way and radius is, let us say, this. So radius formula is mv by qb. B same, charge is same, mass is same. So radius depends on what? Radius depends on proportional to speed. Correct? Definitely, radius decreases means speed must be decreasing. So speed must be decreasing means it is slowing down. What about the uh, nature of the charge, positive or negative? So let's think about this. So the charge particle velocity is this way, v cross b. Suppose b is inside, right? So v cross b direction must be which direction? Think about it. V cross b must be this direction, right? This direction is v cross b. Now, if it is a positive charge, then force will be upward, but because force is downward, why? Because center is down, right? Here is the center. So this must be the direction of the force. Force is opposite of V cross V means charge must be negative. Q is negative, right? Charge is negative and speed is Charge is negative and speed is decreasing. So correct answer will be option B. Clear? Let us move next. Question number 9. In if an electric dipole is rotating about its center with a uniform angular velocity. Suppose this is a dipole. This is minus q, this is plus q, right? Anti-clockwise direction. So which direction should we take as? Suppose this is going, let us say like this, it is rotating. And they are saying constant angular velocity is constant. Angular velocity is anti-clockwise and it's a uniform angular velocity. Okay. Magnetic field is there, which is the direction of the angular, which is in the direction of angular velocity. So magnetic field is in the direction of angular velocity. Now see, I think you know that angular velocity is this way, means angular velocity is anti-clockwise. Anti-clockwise direction means what? Anti-clockwise direction means thumb is coming outward. When you turn your fingers anti-clockwise, thumb is coming outward. Outward means angular velocity is outward. So if angular velocity vector is outward, magnetic field is also parallel to that, it is given. So magnetic field is outward. So suppose if I am taking magnetic field also outward, right, dot. Now which is in the direction of angular, then we have to see, first of all note that angular velocity constant means there is no angular acceleration, so there is no torque. Net torque is 0. There is no torque. Okay. Then show net magnetic force as well as torque. Okay. What about the force? What about the force? Now let us try to see the forces. Suppose if you see particularly here, this is going with this, let us say V, right? V. So V will be there, V equal to omega r. Of course, velocity will be different because this is again in a circular motion. So each particle will have some velocity. But what is the force acting on this? V cross B. Which direction magnetic field is there? Tell me. Outward. So V cross B direction will be what? V cross B direction. So force will be this way. This is the force. Magnitude is QVB. Okay. What about this here? Here this velocity is this way. So V cross B direction will be what? V cross B direction will be this way. V cross B direction is this way. But because this is a negative charge, so force on this must act this way. Force on this will be this way, QVB. Now you see on the entire system there is a net force because this force QVB in the same direction. So this whole system is moving like this way, accelerating in that direction along x-axis. Good question, right? So this dipole is rotating, but it is moving with an acceleration, although it is rotating with a constant angular velocity, right? So torque will be 0, but net force will be there. Net force is not 0. Okay. So which correct option? Net magnetic force on dipole is not 0, but net torque is 0. Yes, fourth option, option D, right? Let us go to the next question. Question number 10. A proton is moving in a uniform electric field E of unknown magnitude. So there is a proton plus E and this is moving in some unknown field. We do not know anything about field, neither the direction nor the magnitude. There is a uniform magnetic field pointing in y direction. Okay, they have given that. Electric field we do not know, but magnetic field is there, and the proton is moving in an electric field E. E we do not know. Magnetic field we know. Magnetic field is along y-axis. Along this y direction, magnetic field is there. Okay. Uniform magnetic field value also they have given 0.01 Tesla. Now, the proton moves in x direction with a constant velocity. They are saying that it is moving in this direction with a constant velocity. Velocity is constant. How can velocity constant? That means acceleration 0. That means it is in equilibrium. How can it be in equilibrium? Magnetic force may act, right? So that means electric force and magnetic force will cancel out. First of all, find direction of magnetic force. V cross B, V cross B direction is coming outward. Note that V cross B direction, Q V cross B direction, that is the magnetic force direction. and magnetic force direction will come in which direction? K cap, because this is x axis, right, and this is y axis. So magnetic force v cross b direction, I cross j, it is coming outward, right? So magnitude will be qvb, right? Now this force has to be cancelled due to what? Electric force. So electric force, that means electric force and magnetic force must be zero. So electric force must be opposite of magnetic force. Magnetic force is in k cap, so it must be minus k cap, right? So the electric field must be inside, right? Electric, because charge is positive, so electric field and electric force direction is same. So electric field will be inside first of all. So electric field must be cross inside. Now what is the magnitude? Magnitude you calculate. So charge into field E, and this is QVB, right? This got cancelled. So electric field magnitude is nothing but V into B. V is given or not? Hmm. How much is the velocity? Yeah, velocity is given 10 kilometer per second. So 10 kilometer means 10 into 10 to the power 3 meter per second, and magnetic field is given here 0.01, 0.01. So this become 100, right? It will get cancelled, so it will become 100. So electric field value SI unit is 100 and it is inside cross. Now check that. Electric field is 100 volt per meter in negative z direction. Yes, that option is option P. Fine. So I hope you got these questions. These are very fundamental questions which is checking your very basics. Right now it is not complicated questions, but if you go through these problems, it will definitely make your base strong, right? So please do attempt the next papers. I have also created the next test paper. So thank you for your attention, then we'll see in the next